This is the Earth Science Classroom. Welcome back. This video is all on watersheds. Watersheds is part of hydrology. It's the water that's going to flow down over the surface. And we're looking at different types, the characteristics, and how the different landscapes and bedrock and different variables can affect the watershed and how this water makes its way over the land, down through gravity and through different slopes, eventually end up in the ocean. So the watershed goes by different names, different terms, but the general gist is the flowing of water down a slope from the land towards the ocean or a lower elevation, like sea level. So this watershed is, when you look at a river, these beautiful rivers, picturesque landscapes, you really don't capture the whole essence of a watershed because there are other things involved than just besides the water. So how the water got there and how the river formed from its origins and headwaters and source to its final destination, which is going to be a delta that enters into a ocean or a large lake perhaps. But the watershed is a large, complex combination of different terms and processes that eventually you see culminating in a river. So this is a fluvial system, a river system that contains both the hydrology, the water, in terms of geology and geomorphology and landscape relief, also involves the atmosphere, and this combination of processes and spheres goes by different terms. Now in some areas it's called a watershed, in some areas it's called a catchment area, in some areas of the world education it's called a drainage basin, and basically it is an area that collects precipitation of different types based on climate and temperature, and flowing of water from the source down to the destination. But these different terms all basically mean the same thing. It's part of a river system and a fluvial system, and we're just discussing watersheds in this video, but the terms are interchangeable between them: drainage basin, catchment area, and watershed. So we can use this basic diagram to gather information and have an idea of what this watershed or drainage basin or catchment area actually is. So you got this schematic and you have the river flowing down through the lower relief or lower elevations of the landscape. So this is based on certain factors. The factors range from the geology and the rock type to the soil, the percolation rates, how the water is going to flow either over the land or surface runoff, or will it percolate and go into the ground and flow through the ground and collect, because the groundwater is going to flow the same as the surface water. It's going to flow through gravity and flow at a certain speed through the rocks and the layers based on permeability, and it's going to eventually end up in the same location as the river, the lowest point in the relief, and that's going to flow down through gravity down to the lowest point, which is generally going to be the ocean, that kind of river delta. And you get the flow of water through the soil, which is siltification, which is the mass of movement down towards a lower elevation, and you get the groundwater flow plus the surface runoff. Now the surface runoff can be in various levels or sizes. It starts off with rills and gullies and channels, and builds up to being brooks and creeks and small rivers, and they are tributaries that kind of flow into the main river, where the accumulation, the mass of the water is going to be held at the lowest point and flow down. Now this is going to cause weathering and erosion rates and sediment load, and carrying sediment down with the water as a fantastic erosional agent, and it's going to shape the land over time. And this can also be looked at with glacial erosion and surface runoff with soil erosion. So there's lots of different factors that can go into this very basic diagram, and we can really extrapolate as much as we can from this in terms of the climate, the elevation, the gradient or slope and the relief, and how compact the soil is, and the materials on the surface, and how easily they're going to be transported and moved, and migrated down with gravity or the mass wasting or mass movement, and also the addition of water and how water is going to move sediment and material very easily. So the climate's going to adapt and control how much precip, what kind of precip you're going to have, and therefore the amount of water and discharge the river's going to have in that certain location, plus the gradient. Gradient and gravity is going to cause the flow and the velocity of the water to increase, and therefore increase exponentially the potential for erosion and weathering of that landscape and the transport of material down the slope. The groundwater, again, with chemical weathering, can cause, based on the geology, whether it's a karst environment or not, can also create different landforms and geomorphology like caves and caverns and the flow of water. So this is going to show you an overview of what a catchment area or watershed actually is. It's the land that catches the water and the extent of the drainage of that river system down to a lower elevation where you have the main river that's going to flow down to a lower elevation. And here's a cool fact for you. So if it rains on a certain catchment area or drainage basin, certain area of the landscape, 1 inch of rain equates to over a square mile of a watershed, equates to over 17 million gallons of water. It's going to accumulate in this system, in this catchment area, only after 1 inch of rain. So you can see if it rains heavily in certain areas of the catchment area, that water is going to flow down over surface runoff or groundwater or through the soil, and it's going to accumulate and create a large amount of water that's going to flow down this system down to the end destination. So 1 inch equals 17 million gallons of water. So a watershed is a river system. So the main river is really called the consequent stream. It's the stream that is the main one that is going to flow down with the majority of the water as it collects from this watershed, as it flows down to the lower elevation. Generally the large amount of water, the discharge. Then you have smaller streams that feed in, so tributaries, but these are called subsequent streams, and they add into the main consequent stream. But there is a stream that kind of flows in the opposite direction based on relief and the landscape, but it could flow the opposite direction to form a confluence where they meet, the tributary and the main river meets, and this is called an obsequent stream. Now there is a stream that could form later, which is at a lower elevation, that could form later on in the system, which is called a resequent stream. But the main ones are consequent, subsequent, and occasionally obsequent based on direction of flow. After the basic river system and how the river is constructed between the different types of streams, which is consequent, subsequent, and obsequent, you get this general design of how the water flows over landscapes, and this is called the watershed, the drainage basin or catchment area. And of course they come in different patterns and therefore different names of each pattern, and these are listed here. So dendritic comes from the Greek word meaning tree-like. So it looks like a tree with a central, starting point by the base, and it branches out into this tree shape. So this is a very common watershed. It's based on a high relief away from the source, at the source, away from the destination, the outlet, the delta, and the flow of water down through a change in elevation, usually sharp, usually a high relief area, a mountainous area, where the source and headwater begins and it slows down, and the different stages of the river are there from the upper level, middle to lower course, and you have this tree-like shape and structure, and these tributaries are going to add in and produce water going down into the river. Now, parallel just means that these rivers are flowing next to each other, adjacent to each other in the same direction, based on the relief and the slope, and they could have small tributaries, they could have small rivers but they are kind of separate river systems, maybe in a coastal area flowing down from a higher elevation down to the ocean, but this is generally going to be a less common situation where the rivers actually stay separated. So this rectangular situation of watersheds comes from the weather and erosion of certain rock types that would allow joints and fractures to be formed on the surface, and then the water is going to flow through these joints, through this joint system and fractures on its way down. Now, this usually can occur in this kind of like straight line, right angle situations based on the geology and the rock type, but usually this situation is in rock that is either less resistant in certain areas, and that forms the joints and fractures, or an arid region where you have these ephemeral streams that happen on flash flooding situations and causes this situation to occur where the straight lines and rectangles are created on this watershed river system. So this is a trellis watershed where you have these areas of landscape that are like a ridge and valley situation, with you have an anticline and syncline where you have these areas of high resistant rock types mixed in with these valleys that are lower resistance, so the water is going to flow through the valleys, the lower elevation, and create this kind of trellis. Now you're going to have these consequent, subsequent, and even obsequent streams that are formed in this area based on the direction of flow and how the tributaries match in with the main river to flow down to the outlet and the discharge. But you have this valley and ridge system creating this trellis, really cool looking watershed design. But you do have other less common watersheds where the water is going to flow in certain directions that creates different kind of designs on the landscape. Centripedal is where you have a location of a lake, a central lake, and these rivers are going to flow into the lake in this lower elevation. So all around these rivers flow in. Radial could be a high elevation peak or a mountain peak or a volcano where the rivers are formed, the source and headwaters form on the slopes of this central peak, and they flow down in all directions around this high elevation like a volcano. And then you have annular or circular, where again you'd have this circular pattern of an anticline, perhaps similar to a radial, but it's more of a circular design of rivers around this one point, the starting point. So after all of these different types of drainage basins and catchment areas and watersheds, we can look at some examples around the world, and there are some absolutely massive watersheds that cover a great deal of land area across the continents. For example, the Mississippi watershed or river basin or drainage basin is huge from the Appalachians to the Rockies. You have the Nile River catchment area, which is huge in Africa, the Congo, the Yangtze. You've got the largest in the world, which is the Amazon, which flows through and produces this amazing ecosystem and biome, which is the Amazon rainforest. But the river is really the heartbeat of this whole system, and it's absolutely massive, covers majority of the northern part of South America as in the continent. It's huge. These massive watersheds could be small, in small square miles, or up to 7 million square kilometers, which is the Amazon. Thank you so much for watching the video. I hope you enjoyed it.